Hello everyone. Last session, we walked through the pre-training pipeline from Hugging Face tutorial. And this is the Colab link. Feel free to have a look. We also look at Andrea Karpathy's lm.c repository, which includes this effort about reproducing GPT-2, 124 million parameters in 90 minutes for $20. Also, highly recommend you guys to have a look and also see in this thread how other people try to reproduce this GPT-2 model. Okay, and then let's look at GPT-3's Wikipedia page and see the estimated cost. According to Wikipedia, we can see it will cost around 4.6 million US dollars, which is huge. All right. Obviously, you can break it down to computing infrastructure, data storage, energy cost, research and development stuffs. All right. And if you look further, in 2020 to train a GPT-3 on a single GPU, that will take 355 years. 355 years. This is ridiculous, right? To lower actual training time, you have to use more GPUs in parallel. I guess these just leads to this GPU go rush. All right. I saw a news from Microsoft. They opened this AI supercomputer exclusively for OpenAI to train different models, obviously. And in this supercomputer, it has 285,000 CPU cores, 10,000 GPUs, and 400 gigabits per second of network connectivity. All right, that's crazy. And let's quickly jump back to their GPT-3's technical paper. All right, that's one interesting thing. They try to address a potential data contamination of downstream tasks. Right, their effort is to remove the overlaps within the development and test sets. However, due to a bug in the filtering process, okay, not all the overlaps are removed. However, they admit that because of the training cost is so high, it's not feasible to retrain the model. Right? All of these just demonstrate the huge cost to train a large language model. All right, let's quickly focus on this. Okay, this chart is total compute used during training. You can see this chart, especially for GPT-3 series. This GPT-3 175 billion parameter, it just so many training effort has been put into this. Right? Let's look at this. It's called petaflops days. Okay, flops is just a floating point operation per second, and peta you just multiply it by 10 to the 15th power, which is a huge number, and then you multiply per day. That's 24 hours, and then you can see the detailed calculation in this page. Right, you see this table, these numbers, right? It's just very huge, right? It's barely possible to train this GPT-3 in a commercial computer. I don't think it's doable. All right. Let's quickly look at this page again. All right. I guess, in fact, challenges are more than just computing resources like GPU. All right. Because they feed 300 billion tokens into the model. This massive amount of raw data set, you need to store them. Right. Data storage, and also 175 billion parameters load up in memory in this float point 32 format, right? You need huge amount of memory. And also networking, right? Has to be high bandwidth, ultra low latency, and huge throughput, right? Consider this from engineering's perspective, right? We can just imagine training a model fully in parallel and in a distributed way over a few thousand GPUs is just quite challenging. I just can't imagine, right? And this training pipeline has to be highly fault tolerant, right? With robust checkpointing. It's just so many challenges, right? And as a result, we can also see lots of effort, especially research-wise. They just focus on something called distributed training strategies. Okay, something to highlight is this fully shared data parallelism and distributed data parallel frameworks. Okay, in fact, if we look at Andre's another repository, NanoGPT, In his training script, he used distributed data parallel. I believe the configuration is just over here, right? Just configuration is just over here. All right. As we can imagine, this training cost is a lot, and specifically, pre-training will just dominate this overall cost, right? If we do not consider inference cost, right, then this pre-training will take about like 95 or even 99% of total compute budget. The next stage, which is this supervised fine-tuning, okay, it will take maybe less than 5%. Well, basically because this pre-training will just take longer, consume more tokens, and then tune all the parameters. In this case, it's 124 million parameters. But supervised fine-tuning, they only need to train a subset of parameters, or even 1% or less than 1% of the total parameters, and only train on a smaller fine-tuning data sets. We will definitely cover how to fine-tune a GPT-2 model later. Let's quickly check out how OpenAI evaluates GPT-2 and GPT-3. From GPT-2's technical paper, we can see GPT-2 demonstrate a strong capability of performing different natural language processing tasks like Q&A, translation, reading comprehension, and summarization. Simply having this transformer-based architecture and train with large amount of web pages dataset. All right. He also mentioned without any explicit supervision, meaning models do not need to go through this supervised learning. We do not need to feed the model with labeled task-specific dataset, right? GPT-2 could easily complete these tasks by predicting the next word and generating coherent text, which is quite impressive back at 2019. And then that explains why the title is called Language Models are Unsupervised Multitask Learners. Okay, we can look at OpenAI's blog post on GPT-2. It used zero-shot prompt to evaluate the performance. We can see from this table, GPT-2 pretty much outperformed all of these data sets, either evaluated by accuracy or perplexity, or these are bits per character. Okay. They also mentioned for other natural language processing tasks, they managed to get surprising result without any fine-tuning, right? Which is very positive. Simply doing this zero-shot prompt. Okay, let's quickly switch to GPT-3's technical paper. Okay, in this paper, it mentioned that they did scaling, all right, and then improve the performance. Let's just verify this scaling law. To get a better performance, you need more parameters, more data set, and more computing budget. Okay. In this page, it also mentioned a few other things. For example, it mentions for all tasks, GPT-3 did not do any fine-tuning. They simply do this few-shot prompt. Okay, and then they achieve very strong performance on different natural language processing data sets, which is very, very impressive. Okay, in terms of this few-shot prompting, it simply means we provide a couple of examples in the prompt, and the model could easily pick up the pattern from the given context, and then give you a better output. And compare with this zero shot. Compare with zero shot. Zero shot, you just do not have any examples. Okay, just ask it to complete a task. That's the key difference. Okay, and I guess this also explains why in GPT-3's technical paper, the title is Language Models are Few-Shot Learners. Okay, let's look at a few other diagrams in this paper. For example, in this page, we can easily see, based on this chart, you have more parameters combined with this few-shot prompt. You always get a better result. Okay, see a few other ones. For example, at this page, you get a similar pattern. All right, larger models and also few-shot prompt, you get a better accuracy. Okay, in this one, for this trivia QA, larger models with few-shot prompt, it even outperformed this fine-tuned state-of-the-art result. Okay, and I guess all of these research results just make this prompt engineering very important and very popular, right? Because good prompt indeed can enhance the model's response. If we look at one example over here, okay, he also mentioned about zero shot and few shot. Right, start with zero shot and then few shot, and neither of them work, then do the fine tuning. Okay, in this case, example is extract keywords from the context. Okay, zero shot and few shot prompt. Let's also not forget about the limitations about these large language model. In the case of GPT-2, he also mentioned GPT-2 does not distinguish fact from fiction, which is very serious. It also reflect bias inherent from the training data, which is far from neutral. All right. In the case of GPT-3, he also mentioned other limitations. For example, he mentioned it has limited robustness, okay, a bias, and then open-end system have large surface areas for risk, and safety is a moving target. This just refers to those attacks like prompt injection, model jailbreaking. Okay, and also it keep mentioning about the model could generate text that contain falsehoods and express them confidently, which is the pretty much hallucination. All right. It also mentioned that it can only be expected to provide reasonable output when given input similar to the one present in its training data, right? So this generalization is not very great, right? It simply memorizes the existing training patterns. Okay, so as a result, ethical and responsible use of AI is also a very important topic. Okay, yeah, thanks for watching. I will see you next time.